All right, it's time to get started. So I'm going to recap quickly what we did last meeting for those of you who weren't here or who missed it. So some of the research areas that we talked about last time were machine learning, natural language processing, NLP, computer vision, robotics reasoning, and AI safety. So these are all related artificial intelligence topics. Each of them distinct in their own ways, each of them with subsets as well. So for example, for machine learning, that would relate to neural networks, that would relate to LLMs, that would relate to transformers, sorry, technical term that so let's say OpenAI, for example, uses LLMs, and those are transformers, and that uses machine learning. So there's different intricacies to each of these topics, research areas. So for reasoning, for example, there's the problem of logically coming to a conclusion about a specific subset of data. Let's say you're coming to a conclusion about a corpus of stock data. What is the conclusion that you could come to for maybe the Fortune 500? Well, it could be the trend up or down for a particular time. It could be a particular city, for example, that has certain aspects of the stock market that they are centered around. For example, let's say in certain city areas, they're probably not going to have as much stock market trends relating to farming because cities, whereas somewhere like Illinois, you might have more. So there's different kinds of research areas in AI. So there's different types of learning in AI as well. It comes down to supervised, which basically means giving an AI some data that is labeled specifically. Let's say you have a picture of a cow, and the AI knows that that's a cow by default. However, with unsupervised, you give it the cow and you just kind of let it figure out what that means in relation to the other points of data. And then you have reinforcement, which basically means telling it it's a cow and saying, well, I'm sorry, not telling it it's a cow, but giving it a picture of a cow and saying, okay, give me what you think this is. Is it a cow? Is it a cat? And positively or negatively rewarding it for determining the right label for that image. And so those are the types of learning. So there's a further detail into those. Basically what I explained. 1,000 photos, labeled cat and dog. Tell me which photo this represents. 1,000 photos randomly chosen, cars, cats, cities, things of that nature. And then you have reinforcement. So figure out how to win this game. For example, let's say you train an AI to play a video game. Well, what are the rewards and what are the negatives? Well, maybe in a fighting game or an FPS game, shooting game, it's death or killing the enemy, for example. And that would be reinforcement. So getting killed could be positive, dying would be negative. And it would have to figure out, okay, the actions that I took along the way, which of these were positive and which ones were negative. Those are the types of reinforcement learning, as well as supervised and unsupervised. So the basic training process that we'll probably go over today is, the first step of every training run when you're training a model is first you get all of your data, collect all your data, label it, process it, pre-process it, sorry, that's the term. Maybe you segment it to certain subsets. For example, you have a testing set, a training set, and a validation set. The first set that you usually do or you work with is the training set, and that's where step 2 comes in. And then for testing and validation, that's where the third step would come in. And so, yeah, those are the 3 subsets that each relate to the 3 steps. So there's a couple of problems with typical training processes, and mostly relating to data bias, as well as the process in which to train them. So the first one, data bias, comes down to certain trends that are found in the data. So for example, let's say you have a subset of data around animals, and unfortunately, for some reason, whether through their intentional or unintentional reason, this data of animals doesn't include wolves, let's say. And that's bias, right? This is a failure that this AI would go through if it were to train on. So that's one form of unfortunate failure. And then you have overfitting, which, as it relates to the data, would come from having too many of one particular animal in this subset of data, which would effectively say, oh, well, obviously all of the data is about cows or about cars. But in reality, there's actually a few examples of non-cow images. So and that would be overfitting, which essentially means it's memorizing a particular pattern in the data, and it's saying, oh, well, I should just answer this all the time because it's the highest reward, or it's the most common thing in the data. And that's overfitting. You're overfitting to a particular trajectory in the data. And then there's adversarial data. So that would come down to adversarial. You're adverse to the objective or to the training process. And that means you're basically not aligned with the objective. So let's say you have these images of animals, and you have a car, but it's not an animal, right? That would be adversarial. Okay, so this is the main part of this meeting. We have an interactive activity, which basically we're going to be modeling together a reinforcement learning process. And that means doing trial and error through a certain couple of steps, however many we have time for. And then we'll do feedback at each step. And we'll basically learn together how to best form a choice. We'll each have a choice to make in this process, and we'll learn how to best make our choices. So this is the process. We're going to learn together. Basically, someone or one of our faculty is going to choose a specific word or a specific topic, and they're going to tell one other person or a group, depending on which way we think is best.
I think with this many people, do we want to let the where we have also?
Yeah, so we can let's count up. So if 21 people, with 24 or 25, so 25 altogether. So we could split us up by 5s, or so we want one person to start off. So that's you. Sorry, this is a bit ad lib.
I can just do 4 groups of 5 and just
4 groups of 5 with
20 members, right? You'll be the output, but that's 22 remaining. There's 3 groups will have extra.
sure.
All right, if y'all wanna do the system where like I'll go around, I'll give you a number, from 1 to 4, okay. I'll give you a number from 1 to 4, and then y'all can each pick a corner of the room, and then we'll simulate. Basically, the idea is we're going to simulate reinforcement learning. I, as a facilitator, will give the first group a word. The group will be like, okay, so let's put our heads together. What related words, without saying the actual word, what are some related words that we can pass on to the next group? The next group is gonna get that word, get those words and be like, okay, let's put our heads together. What do we think we can, without repeating again the same word, what are some other related words that we can put our heads together to give to the next group? At no point will there be like repetition. So you'll keep passing it on. We're gonna have 4 groups, so technically will be like 4 batches of words. And then finally, the last group will be telling their words to Patrick. Patrick will be like, okay, so these are the context clues I have. Let me guess what the concept that I initially started was. And then he'll be like, okay, this is the final guess. He'll say that to me. I'll be like, so that's not right. Let's do it again. And then I will basically move on to the first group. They'll put their heads together again. Okay, be like, okay, so what did we do wrong? Let's think of new words. Let's think of more relevant words to pass on to the next group. And then we'll repeat the cycle until we both have the same word in mind. Everybody get the idea? Okay, perfect. I'm gonna go around the room. I'm gonna say a number to you. And then if you want, we can pick corners of the room. Would that be 1, 2, and then 3 can be this area? That be 4, and then we can all go to each corner of the room, and then I'll go around. Does that work?
I've seen so many cybersecurity things. Have you seen those videos? The guy has with the plug, he plugs it in, and then like he knows he's able to get every information from that. Yes, what's the channel? Something. That's pretty interesting. There's also like ones where like it's just a bit bigger than this, and you plug it in, and then you can exchange information for like. I think it costs like 10,000. Let me just keep it on this side.
No, people. First year it was out.
There's a lot of water through the are you
Do we have our words yet? How is that otherwise?
No, but the difference is like, right? You got that. I think.
They only, you never know which beginning.
No, you don't have those. Oh, you just put the one. No, you just put the one. Yeah, you're good.
We're gonna go
We're not giving them feedback. I mean, they're giving you feedback.
So we're.
Yeah.
Figure out what the tools are.
I think. Single.
Yeah. I guess we can.
Oh, I think it's turned off.
Yeah. But like,
Are you still gonna do another activity or you're not? Right.
We'll just do this.
So what is yeah, what I oh, so I went to
This time we're
Sorry, getting back. We have our final round. And now it's time for a final guesser to guess what word. The
Okay, so once again, from our testing and our validation previously, I think the answer for our 4 words here is DNA.
that is correct. Yes, yeah, raise your hand. All of y'all know. And you're like, I see the answer right there, but I can't figure it out. Like insane, as a facilitator, but the idea was basically that you have an input, me, facilitator gives the input. I give to the first node, they are like, okay, let's come up with most related words. They're the most accurate node out of the entire process, because they know the word, right, obviously. And they pass on their kind of knowledge, related words, to the next node. They're like, okay, so this is what we're working with. Let's think of some more around this. And they come up with new words. This set of new words, this pass on to the next one. And you guys repeat this entire process again and give it to the final guesser. The guesser guesses, I do the feedback, which is called validation process that we looked at in the data split, saying, hey, that's right, hey, that's not right. That's called trial and error. And then we pass it off and do the entire thing again until we finally get the right one. And that is basically what the idea is. If you want to.
Yeah, and just to kind of give a particular reason why the first run is usually never correct. And the reason for that is random starts. So it's training most of the time to get the highest possible range of actions for the best chance of getting right. You start at random spots, a random set of actions. So you could have, if you wanted to, chosen something completely different outside of the realm of biology or DNA or And I still would have had to take a guess, right? And the point of that is, basically choosing a random place and learning from there, okay, this worked, this didn't work, that worked. So at the end here, what I learned, personally was basically it seemed like from the words here, the only thing that stayed true was DNA. So that became my final answer.
And the facilitation that I did saying, hey, that was helpful. Hey, that was mid, remove that. That's like borderline, not technically relevant, considering that I had to do some sort of feedback. Because my feedback process is also like, hey, I know the word, but like a little change may need to happen. Because me as a person sitting outside, the human, I don't like, I just see numbers. The little weights, the papers that y'all have, I just see like, hey, those are weights technically. Those are numbers. That tells me, hey, so this is how accurate you have it, hey, this is not. So once in a while, I'm gonna make a mistake, and that was the point of I have to tell you to cross something off, or I have to tell you to hey, change the thing. That was the big thing. Any questions from that? I know we had like some fact checking on this side of the room, which I apologize for, but any other questions?
Yep, one question.
Is this a reinforcement or supervised?
Yeah, this is reinforcement.
Yes.
Essentially, the positive was the correct answer at the very end, and the negative was the wrong answer, right?
And the idea behind the supervise is also the type of data that you give it. So I initially I gave my data to, and it initially was like one word. So I'll tell you from my research experience, like real world example, is I'm working with a music piece and it's like an MP3 file. I as a human listen to this and be like, okay, so this emotion is sad. That sad is my label for that MP3. When I pass it into the model, the MP3 goes, my word goes. It learns that, it's like, okay, this equals sad. However it processes that is out of the scope of this workshop, but it's like, hey, this is sad. And then it learns that until I feed a bunch of them, be like, hey, sad, 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 sad. Problem is if I feed sad, 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 it's not gonna know what's happening. So that was the big thing.
Yeah, so that boils down to supervised, where you give it the answer explicitly, like, okay, this represents this. In this case, we would change the process from, okay, this is a set of related words, because essentially the reinforcement, the model is guessing. It doesn't know the answer. It's not given the answer explicitly in the data. It just has to guess. And so that was my part, doing the guessing. So the positive made a change, or the negative, sorry, the negative forced me and you guys, the model, to change their processes somehow to arrive at a more correct answer. So because we had a thing. Whereas in supervised, it's explicitly given, okay, DNA is the answer. And these are all the related words under DNA. So therefore, if I see any of these related words together in this sequence, for example, at the very end here, we got DNA, biology, living, and mitosis. It would be given those four words and it would point to directly DNA. And so it would know, okay, when I see these four in sequence, it must be DNA, right?
That's correct. You did a much better job than I. But yeah. Any more questions? Okay. Heard. Yes.
All right, that'll be the end of our presentation today, but we'll be asking questions.
Yes. I know like this is super interactive. Any questions related to like specifics of how we did things? Feel free to come ask. We can fact check.
Real world or, I'm sorry.
Yes. And then in the future, we'll start doing more like, hey, let's sit down, bring your computer, and start coding. Fingers crossed that will be next. Thank you so much for coming, Cole. my God.
But also, I have a question. What do you say certificates involved in that?
We wanna turn the thing off, right?
Like any certificates that you have, like.